Hello guys, we are back again. We are going to be learning about 2.6 today. And 2.6 is all about transforming equations. So think back to what we've done in 2.1 through 2.4, we learned about how to solve an equation. Typically it was the variable x, but we would isolate the variable. And then once we isolated the variable, we would figure out what it equaled and then we would move on. And look, we had some special cases where there were no solutions or infinite. But by and large, we had one variable, we solved for it using the inverse operations. Again, if you're confused about that, go back and look at the 2.1 through 2.4 videos. Well, in 2.6, we're going to be doing a similar thing, but we are going to have more variables. And so now it's not just solving for the variable, but solving for the variable we are interested in. Sometimes this variable is in equations you already know, but isn't isolated. What am I talking about? So to get more real world with this, we aren't just going to use basic equations. We're going to use actual equations that we see in life. Take this one for example. P equals 2L plus 2W. Okay? P equals 2L plus 2W. If you think about this long enough, you're probably going to recognize that this is the formula for perimeter of a rectangle. 2 times the length plus 2 times the width equals the perimeter of a rectangle. So what does solving equations have to do with this? Well, this equation, P is already isolated. P is by itself. But what if we wanted to find another variable besides P? You see, we won't always have the length and the width and try and find the perimeter. What if we have the perimeter and the length, and I need to figure out what the width is? I need to manipulate this equation so that width would be by itself, and that's what we're going to do in 2.6. Now we're going to use the same steps we have been. It's just going to look a little different, okay? So let's say I'm trying to get W by itself. Again, I am interested in W. As far as I'm concerned, P and L are like other constants because I'm not focusing on them. I'm focusing on W. So what's my first step? Well, if you can imagine, like I had an equation 7 equals 5 plus 2W, you tell me subtract 5 and then divide by 2. Similar concept here. My first step is going to be subtracting 2L from both sides. Again, I'm trying to get W alone. I need to get rid of the 2L and the 2. Again, the 2 is multiplied, so we deal with the addition subtraction first, then the multiplication division. So what comes after that? Well, I've got this P minus 2L over here, but it's actually just going to stay as P minus 2L. You can't simplify P minus 2L because they are not like terms. So we just leave it written as is. Okay? The second step and the final step to get W by itself, again, our original goal, divide everything by 2. When I do that, the 2's will cancel on the right side, and I'm just left with W equals P minus 2L over 2. Is there a little bit of simplification you can do? Yes. But again, I am totally fine with this as the answer. I'm not going to make you do any more simplification than this. If you are curious, you could simplify these 2's, but I don't want to get too much into that because too many people end up doing it wrong. I'd rather just have you leave it as this fraction. Again, does it look nasty? Yes, it does. It does not look like a nice, neat math equation that we're used to. But the process, which I hope you're recognizing, is exactly the same. Let's try another one. Let's say D equals RT. Again, this is the formula for distance. Distance equals rate times time. But what if I'm not looking for a distance? What if I have a difference or a distance and a time, and I'm trying to find the rate? So what am I going to do here? Well, I need to get R by itself. R is being multiplied by T, the variable for time. So I divide both sides by T. Again, the T's will cancel, but D and T are not like terms. So I'm just going to leave it as D over T equals R. Again, might not look as nice, but it's the same process we've been doing. Okay? Pick your variable of interest, get it by itself. Let's try a couple more. Let's say we have area equals 1/2 base times height. This is the formula for area of a triangle. But let's say I know the area and I'm trying to figure out the height. What am I going to do? Well, I need to get height by itself. I notice that 1/2 times the base, 1/2 and b are both being multiplied by h. So I can't, if you want to do it in 2 steps, you can, but in 1 step, because both are multiplied by h, I'm going to divide both sides by 1/2 b. This will cancel on the right side, leaving me with h. And on the left, I have a over 1/2 b. Again, if you want to stop here, that is fine. But as you've seen in my classroom, what do we do when we divide fractions? Don't ask why. We flip the second and multiply. We're dividing by a fraction here. So if I flip this fraction, making it 2 over 1, I will then multiply it instead of divide by it. So if you want to do a little simplification, flip the fraction, it becomes 2 over 1 or just 2. And now it is instead multiplied as opposed to being divided. And our final answer is 2a over b will give me the height of a triangle. So I hope you're getting the process. Again, the process should be nothing new. It might be a little overwhelming looking at all the different variables and the lack of simplification because of the lack of like terms, but hopefully you're picking up the process. If you're still very, very confused, this is a great time to pause the video, star your notes, email me with any questions. Okay, let's look at a more familiar looking equation, y equals 5x plus 7. But let's say I want to get x by itself. Let's say I know y, and so I'm going to get x by itself. What's my first step? Subtract by 7, just like we've been doing for a few sections now. Move that constant first, then we will deal with the multiplication or division that's attached to the variable. So I subtract both sides of 7, then I divide both sides by 5. Again, no more simplification I can do on the left here. So y minus 7 over 5 will equal x. Y minus 7 over 5 will equal x. Okay. Next example. We're going to go full variable mode here. A times b minus c equals d. And I want to get b by itself. Okay? Hopefully you've gotten the process down. Again, b is the only variable we are concerned with. So what we are going to do is we are going to move the a and the c to the other side, and they almost act like coefficients and constants. Again, handle your addition subtraction first. Add c to both sides. And I get a times b equals d plus c. They do not add together because they are not like terms. Divide both sides by a. Again, no simplification can be done, and I am left with d plus c over a as my answer. Again, if this video feels like it's moving pretty quick, go back, pause it, rewatch certain parts, email me with the questions you may have. The last problem we're going to do is a challenge problem here. And what I'm going to do is I'm going to challenge you to try and isolate this. Now the numbers look nasty, but this is actually an incredibly important equation. What this equation is the transition of temperature from Fahrenheit to Celsius. If you plug a temperature in Fahrenheit into this equation for F, you will get the output of the degrees Celsius. But the question becomes, what if we have degrees Celsius and we want to find Fahrenheit? Well, it's a very real world application that we need to transition this equation around. Now here is your hint. Again, this is an optional challenge problem. Try it on your own, and you will know you did it right if you get 9/5 times C plus 32 will be your degrees Fahrenheit. Okay? That is the answer you should get. I'm not going to show you the work. Again, a challenge problem. Try it on your own. See if you can't figure it out, and then go one step further and test it with a temperature. Prove me right or wrong. See if you plug in a temperature for Fahrenheit here. Try 77 degrees. See whatever temperature it gives you in Celsius. You plug that in for C, if you end up with 77 degrees. Good luck, guys. I'll check that sometime, the optional if you want me to, and let me know if you have any questions.